Okay, so today we're going to talk about a few examples, and this is about creating histograms. The first one we're going to do is based on a discrete data. Up here at the top, we have 10 rolls of a single six-sided die. Okay, so we got a 1, a 6, a 5, a 5, a 4, a 3, a 2, a 4, a 3, and a 2. But of course, you can read all that. So first thing that you want to do is kind of get those into a list and figure out what the relative frequencies of each of those are. That is what this list over here is. I had 1, 1, so I got 1%. Likewise, I had 1, 6, so I've got, or 10%, excuse me. So once I have all this data, I want to arrange it and I want to put it into a histogram. Very, very important from this histogram that we have our numbers in order. So that way we can see if these things actually matter. If there is a pattern for this. Which there is a pattern that you would observe over time, but you need a large enough sample, which we'll get to that later. But for this, again, for 1, we're going to create 10%, which is the 0.1 here. So we go make this. 2 gives me a 20%. 3 gives me a 20%. 4 gives me a 20%. 5 a 20%. And 6 a 10%. So good deal here. So eventually, over time, when you make a histogram, you can judge a shape. Now this one is not what we would normally expect for a single-sided die. Normally, we would expect a graph about right here, about 16% throughout. Now it'd be a little bumpy because it's never going to be. It's likely to never be exactly perfect, but it could be, and that's what main thing is putting them in order and recording everything down correctly, and you can see that generally there's supposed to be some sort of evenness to this. The second one we're going to do is for continuous data, and this is going to be where you can have data that's all over the interval. So like instead of just getting a 1 for a die or 1 hour or 2 hour, this is between 0 and 2 hours TV watched per day. You have 2 to 4% of people watch, 20% of people watch 2 to 4 hours of TV a day, and 30% of people between 4 and 6, and so on and so forth. So we have our relative frequencies, which is perfect. Now we just have to set up our interval line, which is this here. So we've got 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 plus, etc. So we go again, just like we did before, and plot our points out, or make our bars. So this is 20%, 30%, 20%, and 20%. So again, we have a shape that we can kind of see. It seems like a lot of people are watching a lot of TV. But mainly you want to, again, make sure that hours of TV watched, you want to make sure that you are labeling your axes, and also that the axes actually mean something. That's the difference between a histogram and a bar graph, or a bar chart. Lastly, what happens if you end up with what's called uneven class widths? So if you see here, if you're under the age of 18, okay, that's a lot of ages. You can be 0, or you can be an infant all the way up to 18. Now, not that I would expect an infant to be in college, excuse me, but you never know. You don't want to limit things like that. But this one has a width of 18, while the next has a width of 4, and the next a width of 4, and the next a width of 4, and the next a width of it's going to be 57. Okay, so we've got a large difference here. Now, if we had our number line out and we recorded it evenly to where we did 0 to let's say 8. This is 18. So this would be 36. This would be 54. We would have some numbers in here, but they'd be really, really small. And we would have this 2% look much bigger than it's supposed to be. because it's so wide. It would just seem like it has way more area than it needs. And same thing for our last one, 8%. You would be up, near half for way up here at the top. Not that this is perfect right here, but the idea being that you would have the area would look much bigger than it should. So what we do here is we convert, instead of using relative frequency, we do something called density. And what density is going to be is it's going to be our relative frequency divided by our class width. Okay, that's what that's going to be. Our our relative frequency divided by class width. So real quickly, if I went and did that, I would go and say, okay, well, 2% divided by 18 is going to be 0.11%. 60% divided by 4 is going to be 15%. 15% divided by 4 is going to be 3.75%. And then we've got, this is going to be 3.75%. And 8% divided by 57, well, now that is something there. This is 1/7, a little over a seventh. So if I added these up, I could figure this out, I suppose. Let's see, so this is 6, 7.5, plus 50. Well, hold on, actually that's not good enough. Okay, well, why don't we do this? 57 into 8. We got 1, 57, 23, 0. So would this go in 4 times? So 4 times that would be 228. We got 2, 0. Okay, so we're basically at about a 0.14%. We'll just stop there. Sorry for that. So instead of graphing all this out based on relative frequency, which all of these numbers are pretty close together, we get a better idea of where all these college kids actually are based on density, because these graphs are so uneven. It's not fair to compare a group that has 57 possible ages to a group that has 4. And that's what this is all based about. So if we went through and graphed this, follow me. I've made a dot here every 10, just so that I can make sure that I'm keeping things consistent. So we start off, and we've got up to 18 and 22. We've got 0.11 and 15%. So up to 18, which will be about right here, I've got, what did I say, 0.11%. So that is very, very small. Very, very, very small. These are percentages. Okay? So you basically, in order to convert backwards, you need to move the decimal twice. Okay? So we're talking about, this is a 0.0011. This is a 0.15. This is a 0.0375. This is a 0.0375. And this is a 0.0014. So very, very tiny numbers. So a 0.0011. Oh, and this should be 0.1 and 0.05. So a 0.0011 is going to be very, very, very tiny. So actually, it's probably smaller than that. No, but we'll keep it here. So that's up to 18. So that respects this whole line here. Now, oh man. Alright, what? Alright, I guess I'm not doing that anymore. Okay, so I'm up to there. So now from 18 to 22, which I'm going to make right here, we're up to 0.15. So you can see that even though this is a much wider range, okay, it's much, much wider, we're accounting for that. We're accounting for its area, which is, again, 2% versus the 60%, right? We're making this as dense as we can. Um, and that's roughly accurate, because this is, much, much larger of a group in reality. And now so we've got 3.75% for the next two. And that's 23 to 27. So 0.375. So we got about here. We got about here for the next two. That's up to about 32. Okay, so these two kind of have representative areas, and this has got to be much smaller. And then finally, we've got about the same thing, but from 33 to 80. Right? So even though you have, 8% of your college-going population is over 33, it's got to be spread out over so many ages, so you can't really make it a huge graph. You couldn't put it up here, because that would be unreasonable. You couldn't make it that high. However, this range here, you can see where it's all centered, and it's very, very small. So the taller that something is around a time, the more centered it is around there. But this type of density graph is helpful when you have these uneven class widths. Which again, this is 0 to 18, this is 22, this is 27. You got um, 33, and so on. So 80. So you've got these numbers all the way like this. So anyway, main idea being, if you have these uneven class widths right here, you need to be looking to create density, which again, density is relative frequency divided by class width.